Hello students, good morning. Welcome to our today's maths class. So you know which chapter we are discussing, that is progressions, and that too arithmetic progression. And last exercise, arithmetic progression, last exercise, that is 6.3 exercise, and only 4 problems left. Only 4 problems left, but they are theory problems, theory questions. You have to understand the problem. So remaining up to 9 problems, almost all just the problematic. So no, just starting the formula and getting the answer. But here these 4 problems are like applications. Theory is given, you have to understand, you have to then convert the problem into arithmetic progression, then use the arithmetic progression formulas. So like that. See, all of you read the 11th question. Even if you don't understand also, just read the question. So this is exercise 6.3, 11th question. All of you read 11th question. 11th question. Students, in a class, students are planting the trees. In a school, students are planting the trees. You read the total question and understand. I will give the a brief about that introduction. Total first class students are planting one tree as per their class. First class students, total section will plant only one tree, not one student one tree, not like that. Total section, first class total section will plant one tree. Second class, total second class will plant 2 trees. Second class means 2 trees. Third class means 3 trees. Third class total section, not individual. One student plant 3 trees, not like that. Total section will plant only 3 trees. Fourth class total section will plant 4 trees. So suppose there are 3 sections in each class, but first we will take it as one section only. So see here. Suppose first class total section will plant how many trees? 1 tree. Second class will plant 2 trees. Second class as per their class. Second means 2 trees. Third class will plant 3 trees. Fourth class will plant 4 trees. Up to 12th class. Up to 12th class. Up to 12th class. The school is having up to 12th class. You know, a school means in CBSE or ICSE, in some of the states, school means up to 12th class we call it as a school. But in our state, so up to after 10th class we call it as a junior college. But in some most of the states and even in CBSE also, up to 12th class it is a school. So 12 classes are there. 12 classes. Up to 12 classes. First class students are planting 1 tree, total section. Second class students are planting 2 trees. Third class 3 trees. Fourth class 4. Fifth class 5. Sixth class 6. Seventh class 7. Eighth class 8. Ninth class 9. 10th class 10. 11th class 11. 12th class 12. So how many trees they will plant? Total number of trees. But each is having 3 sections. So after getting the answer, I will multiply with 3. Each is having 3 sections. So I will multiply with 3 afterwards. Or you can just, here also you can multiply with 3. Let us multiply in the last. So, first class students are planting 1 tree, second class 2, third class 3, fourth class students will plant 4, 5, 6, 7, 8, 9, 10, 11, 12. 12th class students will plant 12 trees. Total section will go and plant 12 trees as per their class. If they are 12th class students, they have to plant only 12 trees. Whatever may be the strength in the class, irrespective of the strength, 12th class total section should plant only 12 trees. 11th class students should plant 11 trees, like that. How many trees total? how many trees they will plant? 3, 6, 10, 15, 21, 28, 36, 45, 55, 55, 66, 78 trees they will plant. 78 trees. They will plant totally 78 trees. But we should not do like this. We should not do like this. We have to use the formula. If you observe this, first class 1, second class 2, third class 3, fourth class 4, if they are like this, then this is arithmetic progression. See, this is arithmetic progression. What is the difference? 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is, difference is 1. Difference same means it is arithmetic progression. So we can use the arithmetic progression formula. So first write some introduction. Write some introduction. Directly we should not start. Write some introduction. It will be good. So write down. In a school, write down. In a school, students are planting trees. In a school, students are planting trees. Each section of each class will plant. Each section of each class will plant. Each section of each class will plant number of trees as per their class. Number of trees same as their class. Number of trees same as their class. Number of trees same as their class. Okay, students. There are three sections in each class. First class there are 3 sections. Second class 3 sections. Let us take one section first. After getting the answer, I will multiply with 3. That's all. So first let us take each class one section only. First class one section, second class one section. Like that we will calculate. We will find the total number of trees like this. Then multiply it with 3. So we will get total trees. So write down. Then number of trees planted by the students, planted by one section students of each class. One section. First we will take one section. One section only. Number of trees planted by one section students of each class. Or so one section only. First class students will plant how many trees? 1 tree. Second class students 2 trees. Third class students 3 trees. Fourth class students 4 trees. Like that. There are 12 classes. 12 classes. What we have to find? We have to find the sum. We have to find the total number of trees. How many trees all the students up to 12th, first class to 12th class students will plant. So sum we have to find. We have to add. Now normally we can add, but this is the arithmetic progression. Let us use the formula to get the same answer. See here. This is NAP. This is the arithmetic progression. Why this is arithmetic progression? Difference 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1 difference. This is an AP. A is equal to 1. First term is 1. First term is 1. Common difference is second minus first. 2 minus 1 is 1. First term is 1. Second difference is 2 minus 1 is 1. Sum of all trees. Sum of the total number of trees. Total number of trees planted. Some formula in AP. Total how many trees are planted? This is 1 tree, 2 trees, 3 trees, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15 like that up to 12 classes. So, the formula for sum to n terms in AP is, this is the formula. Directly we can get the answer without actual addition. N is, how many classes are there? 12 classes. 12 by 2 into A is the first term. Plus n minus 1. N is, we have 12 classes. So 12 minus 1 into difference is also 1. 12 by 2 is 6. 2 into 1, 2. 12 minus 1, 11. 11 into 1, 11. So 6 into 13. 6 into 13, 13 6 are 78 trees. How many trees they will plant? 78 trees. 78. See, I got same 78 answer. Using the formula also same answer. If you add also 78 trees. Total first class students 1 tree, second class students 2 trees, third class students 3 trees. If they plant like that, total up to 12th class we will get 78 trees they will plant. But see, this is one section. They have three sections. So suppose A section students, all A section students, first class A section, second class section, all A section students will plant 78 trees. All B section students also will plant 78. All C section students also will plant 78. Total will be 78 plus 78 plus 78, or 78 into 3 times because 3 sections. So write down this. Since each class have 3 sections, therefore total number of trees planted is equal to 78 into 3, because one section means 78. Each class is 3 sections. Each class 3 sections. So into 3, 3 8s are 24, 2, 3 7s are 21, 234 answer. Number of trees planted by this total class is 234. Write down stories. Write down. Understand the problem. Followed or not? Followed or not? First class students will go and plant 1 tree, they will come back. Second class students will go and plant 2 trees, they will come back. Like that. Third class students are going and they are planting 3 trees. Fourth class students are planting 4. Like that up to 12th class students. Total how many trees they will plant? Total first class 1, second class 2, third class 3, fourth class up to 12 classes. So the for A is 1, D is 2 minus 1, that is 1. Sum to n terms formula n by 2, 2a plus n minus 1 into d. A is 1, n is 12 because there are 12 classes. 12 classes. So n by 2 means 12 by 2, which is 6. 2 into A is 1. N minus 1, 12 minus 1. D is 1. 1 into 11. 11, 11 plus 2, 13. 13 into 6, 78. But there are 3 sections in each class. Each class is having 3 sections. So A section students are planting 78, B section for example 78, C section 78. Total number of trees will be 78 into 3, 234. Write down students, read the next question. Students, next 12th problem. These are difficult problems actually because applications. Direct problems are easy. Using the formula, we can suppose if this is given, directly you can do. But how we are getting these numbers, that is understanding the problem and converting it into this AP. That is difficult. So application problems, all these 4 problems are very, very difficult. So now 12th problem. 12th. The problem is also difficult. Since each class have 3 sections, total number of trees planted is equal to 78 into 3. 234. What is the answer? See here. A spiral is made up of successive semicircles with centers alternatively at A and B. See here. Very confusing question. See here. The diagram is given. So simply if you look at the diagram, you can understand. See here. There is a semicircle like this. Semicircle like this. Say L1 is the semicircle. L1. First semicircle is L1. There also it is mentioned. There is this radius is 0.5. The semicircle radius is 0.5. Radius of this first semicircle is 0.5. First semicircle radius 0.5. Next, second semicircle is drawn. Second semicircle with B as center. See, A center, B center, don't get confused. If you look at the figure, that is enough. Direct diagram is given. So there is another semicircle. There is another semicircle like this. See the diagram, it is given. Say this another second semicircle is, for example, L2. Second semicircle, let us take it as L2. Next, third semicircle. L3. Third semicircle. First semicircle L1, second semicircle L2, third semicircle L3, next semicircle, like that 13 semicircles are there. 13 semicircles. 13 semicircles and radius is given. First semicircle radius is 0.5, second semicircle radius is 1, third semicircle is 1.5, like that different 0.5 increase. First time radius 0.5, this first semicircle. Second semicircle radius is 1, third semicircle radius is 1.5, fourth semicircle radius is 2, like that it is given. Now the question is, how much wire is required to make this? How much wire is required to make this spiral? From here it is started. So wire we are using up to here, again we are using up to here, again we are using up to here, and it will be continued like this. So like that it is continuing. 13 semicircles we are preparing. So how much wire is required? How much wire is required? How much wire is required? That is the question. How much wire is required? Now, for this, because these applications means sometimes we use different chapters concepts also, not only progressions. So this is a semicircle means we have to use the concept of mensuration. First I will find this L1, this total first semicircle, what is the wire required? What is the wire required for this first semicircle? From here to here, how much wire we require? First semicircle I will do, second also I will do, third also I will do, and so on I will write. First semicircle, how much wire is required? How much wire is required means wire we started from here and we are keeping, we are bending the wire like this. Our wire is like this, ear to ear. This is nothing but perimeter. This wire is nothing, length of the wire is nothing but length, that is perimeter of the semicircle. What is the perimeter of the semicircle? See here. Perimeter of the semicircle formula, pi r. Circle perimeter is 2 pi r. Perimeter of the circle is 2 pi r. But half circle, this is semicircle, half circle perimeter is pi r. That means, what is the length of this wire? Pi r. Pi into, pi means 22 by 7. We will write later. Or you write 22 by 7 into r is first semicircle radius 0.5. It is given in the problem. First semicircle radius is 0.5. So this L1 length is over. Now I will find the L2 length. L2 length. L2 length. Same, that is it. This is also semicircle. What is the length of the wire? From here to here, if you are making this semicircle, how much wire is required? The wire is nothing but, length of the wire is nothing but perimeter. Perimeter of the semicircle. What is the formula for perimeter of the semicircle? Pi r. 22 by 7 into r is 1. R is 1. Next semicircle. Next semicircle. This is over now. Now L3. This semicircle, how much wire is required? Wire is kept from here to here. This is the length of the wire. So how much wire is required? That is nothing but a perimeter of the semicircle. What is the formula for perimeter of the semicircle? Pi r. 22 by 7 into r is 1.5. So on. Like this. Next semicircle, next semicircle. What is the question? What is the total length of the wire? Total length of the wire. Total length of the wire required to make this total spiral. See here students, don't write. We have to add all these lengths. First semicircle, how much wire is required? 22 by 7 into 0.5 plus. Second semicircle, how much wire is required? 22 by 7 into 1 plus. Third semicircle, how much wire is required? 22 by 7 into 1.5. Like that, how many semicircles we are forming? 13 terms. 13 semicircles we are forming. We have to add all this. How to add? We can add that directly, but it is lengthy, so we are using the arithmetic progression formula. So first, up to here you have to understand. Here onwards, it is very easy to apply the formula. You know how to apply the formula. Sum to n terms is n by 2 into 2a plus n minus 1 into d. That I will explain. But how we got this, you have to understand. There is a semicircle of radius 0.5. What is the length of the wire required? Pi into r. Perimeter of semicircle. So pi into r. Pi is 22 by 7, r is 0.5. Second time, second semicircle, 22 by 7 into 1. Third semicircle, 22 by 7 into 1.5. Like that. Write some introduction. Write down. Radii of the semicircles are 0.5, comma 1, comma 1.5, so on. Radii of the semicircles are radii means plural form. Radii of semicircle, radius is singular. So many semicircles, no, I use radii, plural form. Radii of semicircles are 0.5 centimeters, comma 1 centimeter, comma 1.5 centimeters, comma 2 centimeters, so on. Right, so on. Then their perimeters are L1 is equal to pi r, second perimeter L2 pi r, third perimeter L3 pi r. So why I am finding the perimeter? In the question perimeter is not mentioned, but why I am using the perimeter? Because length of the wire required is nothing but perimeter. This is called perimeter. You studied in the lower classes the meaning of perimeter. So this total length is called perimeter. So how much wire is required to make this first semicircle? That is nothing but perimeter. Perimeter formula is pi r. Pi is 22 by 7, r is 0.5. 22 by 7, r is 1. 22 by 7, r is 1.5. 22 by 7, r is 2. Like that it will continue up to 13 times. So but question is, what is the total length? The total means you have to add. Write down students up to here. After that I will simplify. 22 by 7 common. 0.5, 1, 1.5 plus 2. How many total? 13 terms. There are 13 numbers in the same order. 13 semicircles. Thirteen numbers. See students, same I wrote here. This is arithmetic progression. Why? What is the difference? 0.5, 0.5 difference. 0.5 plus 0.5 is 1. 1 plus 0.5 is 1.5. 1.5 plus 0.5 is 2. 2 plus 0.5 is 2.5. 2.5 plus 0.5 is 3. Like that 0.5, 0.5 difference. This is perfectly AP. Here don't consider this 22 by 7, it will be written same. So only see the expression inside the bracket expression only you see. A is equal to this minus this. Students, 22 by 7 into sum. Here plus means sum. What is the sum formula in AP? N by 2, 2A plus N minus 1 into D. This is the formula for sum of terms. When we are adding the terms, this is the formula. So 22 by 7 into N is how many terms are added? 13 terms. So 13 by 2, 2 into A is 0.5, first term, plus N is 13 terms we are adding. The series is having how many terms? 13 terms. So 13 minus 1 into difference. What is the difference? 0.5 over. So 22 by 7 into 13 by 2 into 2 into 0.5. You know multiplication. 0.5 is 5 by 10. 10 by 10. This is 1, students. 1. 12 minus 13 minus 1 is 12. 12 into 0.5 is 6. You know how to multiply. So 22 by 7 into 13 by 2 into 1 plus 6, 7. 7 cancel. 7 cancel. 2 11 times. So 11 into 13 answer. 11 3s are 33. 3 11 1s are 11. 143. This is the answer. So total wire required is 143 centimeters. Given data is in centimeter, answer will be in centimeters. Students, see here. Up to here you have to understand. Here onwards I need not explain because already we did so many problems. Almost all we are at the end of the arithmetic progression. So you should be familiar with all the formulas. So how to, this is plus. We are adding. Total length means we have to add this length plus this length plus this length plus next length less. Like that 13 lengths we have to add. So addition means sum formula. Sum formula is n 2a plus n minus 1 into d. So n by 2, 2a plus n minus 1 into d. N is 13 terms. So 13 by 2. 2 into a is the first term 0.5 plus n minus 1. 13 minus 1 into difference is 0.5. 13 minus 1 is 12. 12 into 0.5 is 6. 2 into 0.5 is 1. 1 plus 6 is 7. 7 cancel. 2 11s. 11 into 13 is 143 over. So if you are not copying within time, you can watch the video once again and you can copy it. Copying is not a problem. Understanding is important. Copying it not a problem. Even if you don't copy, also don't disappoint. You can comfortably watch the video once again. You can comfortably write. Listening is important. Students, studying the question, you read the question. So broadly, I will explain the concept. There are 200 locks, wooden locks. So first we are keeping 20 locks in the base. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 locks in the base. After that, on this we are keeping 19 locks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 locks on this. On the above, 18, one less. 20, 19, 18, like that. 18, see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. On above 17, on above 16, on above 15. Like that we are placing the locks. So total 200 locks means how many rows we will get? 20, 19, 18, total 200. How many rows? That is the question. So here 17 locks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Like that. How many rows we will get? So that total, one more row, total 200 locks we have to arrange. 20, 39, 57, 64, 64, again 16 lakhs, 15 lakhs, like that. How many we will get? Total 200. Total should be 200. So first time in the base, how many locks we are keeping? 19 locks. 20. Base how many locks? 20. Second time 19. Third time 17. Next time 16. Like that we are keeping. So how many rows we have to keep so that sum should be 200. Sum of all these should be 200. That is the question. Sum of all the locks should be 200 because we have 200 locks only we have to arrange. Write down. Number of locks. Write down. Number of locks in a row, in each row, from the bottom. Number of locks in each row from the bottom are first row 20, second row 19 locks, third row 18 locks, next row 17 locks, like this. Like this the locks are arranged. 20, 19, 18, 17, so on, like this locks are arranged. Okay, I'm okay. So this is an AP. Why it is AP? Difference is one difference. This is an AP. This is an arithmetic progression. Here first term A is equal to 20. Difference is 19 minus 20 is equal to minus 1. How many rows are required to get the total 200 logs? Let number of rows is equal to n. Then Sn should equal to 200 because 200 rows we have to arrange. It is given in the problem. So write down Sn formula, simplify it and get the n value. Write Sn formula n by 2, 2a plus n minus 1 into d. You simplify, students. Otherwise, next class I will tell because time is over. So let us conclude here. And students, if you complete it, there is only one problem left. And